All right. Hello to all of you who are here or watching this back on recording. And welcome to what is hopefully going to be 2.5 hours of pretty condensed math. For anyone that somehow is watching this on recording and has not actually seen the paper yet, I have included the link to the paper in the description below. You can pause this and go and try the paper first before coming back. And yes, for those of you who are here, this session will be recorded. So if you need to like run off in between, or if you're just afraid that you will miss anything, you don't have to go and frantically copy stuff down, right? This is on YouTube. It will remain there as long as YouTube is alive and my channel does not get deleted. So also, yes, the SMO is probably going to be easier. I do not have any reason to believe that the SMO is getting easier and easier or harder and harder. I would just say that the last 2 to 3 years of the SMO are certainly not that easy, but many of you have indicated that no, but they are all easier than what this silly hard SMO is. Too hard already, I give up. Well, we'll talk a bit more about the questions themselves. And after that, you can decide whether you actually think it is that hard. But it is true that if it looks hard, that is hard, right? So which means if everyone thinks the paper is hard, I'm not going to come here and say, no, 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 it's easy. If not, I would have called it easy SMO. It's called hard SMO. So I know it is hard. And so, yes, it is hard. Don't panic. It is supposed to be also very wide-ranging set of questions so that we'll get to hopefully learn a few things about standard-looking topics that you were not aware of before. Now, right off the bat, just like in the junior one just now, I am going to just say cutoffs. And then I'm going to say cutoffs, but right now we have got like around like 15 to 20 people here because everyone is slowly coming in and all the Hwa Chong people are busy marking the APM OPS. So I'll probably have to answer this again later, but cutoffs. These are what I am going to put cutoffs as for this paper based on the stats that I have gotten. Obviously, this is hypothetical. So I can only go based on the submissions I've gotten. I did not take your submissions like just raw scores and average it or something because I know that a lot of you submitted more than once. Some of you told me, some of you didn't tell me, but it is pretty obvious. Some of you did like just submitted one with just the multiple choice. And it is pretty obvious that nobody would say I only solved 5 questions and nothing else. So I think you're just testing the multiple choice. So with a reasonable amount of data that I can analyze it, somewhere around there would be my estimate. It is a hard paper. But it is not like just I decided to make it as hard as possible with no regard for human rights. I made it as so-called instructive as possible. And I can tell you that there is very much a purpose to the design decisions of the paper. As I often mention, right now, if you were to take this hard SMO and put it into ChatGPT, it can solve most of the questions. Right? That is just because these are still questions that have a solution. If you were to ask ChatGPT to come out with an SMO paper, however, it is not yet able to do something that is very much like a challenging paper because it doesn't really understand what hard is. So everybody who took this paper found it hard, but your reasons are not the same. Now, if you're taking SMO for the first time and your aim is I want to get something, right? Something usually means an honorable mention or a bronze. The problem you had is that the easy questions are not that easy. The easy questions often require you to do two things instead of one thing. Or they just look very weird, or they look very scary, or they don't look very weird or scary, but they are still very, very easy to mess up. Now, some of you are aiming to get into round two, which in recent times, if we're looking at these cutoff scores, the recent SMO cutoffs would probably be a little bit higher than this, on average, maybe by like by a point or two for senior. The thing is that if you are aiming for the silver and round two kind of scores, normally it is possible that you can do one of two things. One is that you find a lot of places to just guess answers to get the extra 2 or 3 points, which, remember, please do guess nonetheless. SMO has no negative marking, unlike, let's say, I think Chem Olympiad or Physics Olympiad had negative marking, right? So SMO has no negative marking. A lot of you guys, when you submitted with a lot of blanks, which is fine. You do not need to guess for a mock paper, but for the actual paper, please guess. Whether it be the multiple choice, please guess, or even for the short questions, some of them you can kind of guess by estimation or just guess by like, I think this is the only solution, let me try. But I have blocked it in a way that a lot of the problems which would normally be guessable, the guesses don't work. Now, another thing that is interesting about the SMO Senior is that a lot of the recent years papers have kind of been either mostly algebra or algebra plus combi or algebra plus geom or algebra plus number theory, which means that if let's say that you like geom, then you'll be like, oh, this paper is quite okay, but the other two are bad. Now, if let's say that you are bad at combi, you'll be like, oh, this is bad, but these two are okay. And then most of us do a lot of algebra in school and also for SMO practice, right? So algebra is the one we are most familiar with. For this paper, you kind of have nowhere to hide, lah, right? So I didn't put like a lot of one of them. I put a significant number of each of combi, geom, and NT. You have kind of like 3 or 4 of each of CG and N, which are non-trivial. And what that does is that you don't really have like anybody who says that they find the paper easy, because one of these is always going to cause you trouble at least. Someone's going to say, no, all of these cause me trouble. Well, if all of these cause you trouble, then you better be really good at algebra. But seriously though, it is hard because it is also harder because you need to switch your mindset between these different types. Also, the easy questions got stashed into weird locations. Easy by senior standards. You don't know where to find them because it's just like in between some questions that look pretty hard. Actually, there are some that are easier, but you won't know that they are easier. So it sometimes got buried. Right? And remember that the SMO is not in difficulty order. At least not perfectly. Now, it is true that don't expect the multiple choice to be the 5 hardest questions, but also do not say I'm going to go in order from front to back, and then when I run out of time, 2.5 hours is up, ting, okay, then oops, I didn't read the last 8 questions and actually 3 of them were easy. Right? Don't do that. Finally, of course, there are some of you here or watching a recording that are aiming to get a gold or a top 30. Now, that certainly will be something that depends on round two, right? We know that gold and top 30 and even like gold and top 30 depend on total score. If you're aiming for, let's say, senior team, for instance, that is based on round two only. But you guys, if you are doing this, you may find that there's just no time. Like a lot of you who are watching, or you responded in the form that no time to try the questions behind. yes, that is partially going to be correct, that you are meant to be running short of time. If you look at the last few years of senior, you also be running short of time. But the reason why this paper is difficult is that the easy questions have an even easier method, if that makes sense. So like there is the easy but let's say 5 to 7 minutes method, and there's also the easy, let's say 2 to 3 minutes method. Now, for those of you who are aiming for a top position, then it kind of does matter whether you found the former or the latter method, because the time savings does add up quite a lot. There are also a lot of problems where it is quite easy to take the wrong approach. There are also quite a number of problems where you do need to make a round two style observation. And then the working is very short. But the observation may take a while to get to, whether by experimentation or whether by just like thinking about it for a very long time. So all of these are the many different reasons why the SMO can be hard, but my hard SMO is really hard because it has all of these features all in the same paper, whereas most papers have just some of them. Okay, so I stalled for time enough. I know that there is a lot of things going on today. I thought I picked a day where there's not much happening except APM OPS. I know someone says like, oh, because they are like NUS High has something going on, right? And then some of you were from what, crystal growing competition. I'm very out of the loop, no matter how, because there are more competitions nowadays than ever before. So anyway, I've waited a little bit. A few more people are here, so we can now go through the questions. What I will be doing, just because of Microsoft Word does not seem to like the hard SMO either. It seems to be lagging like after 30 minutes consecutively of writing. So I split it into several documents with 5 questions each, and so after each time I'll just change over to the next document. So then that will be sort of an organic intermission point, where maybe we will pause after 10 questions, and then we'll see where the second pause should be. Okay, so here we go. Now take a look at the time. Right now is 1:13 p.m. Take a look at the time to see how long the method is that I am using. Of course, maybe add 20% because I set the question so I don't need to spend time reading. But add 20% just to see, actually, is it that bad? Right? Is the amount of workings actually as long as you thought it was? Okay, question one. Question one is a standard Vietas question. You have first equation tells you that the sum of roots is 20 and that the product of roots is 26. The choice of 3 and 2 is obviously going to make it such that you have 5 alpha plus 5 beta is 20. So alpha plus beta is equal to 4. That's one of the new things that you need for your second Vietas, right? You need the sum of roots, which now is 4, and you need the product of the new roots, which is alpha times beta. Now, I've got a second equation here, and the easiest way to handle this second one is not to expand it, but to use the alpha plus beta equals to 4. And say that, therefore, I can say 2 alpha plus 2 beta is 8. And expand this one. So put in the 4, and you end up with alpha beta is negative 70. Okay, and that will give you your answer, which is option E. Okay, question 2. Do not differentiate. Now, is calculus in the SMO senior? Usually no. Right? Now, last year was the first time that they just put 2 random calculus questions at the back that didn't really use a lot of calculus, just use a bit. But it is probably the right assumption that calculus is not going to be needed for the rest of the questions unless you see explicitly differentiation or integration being mentioned. So don't try to use calculus. Moreover, whenever you use calculus, the problem is not the differentiation, it's getting the critical points and then checking them also takes time. Okay, so don't do that. This is basically just surds and quadratics. Surds because what you would like to do is to rationalize the second thing. Whenever you have a denominator like this, rationalizing it is going to make sense using the conjugate. The bottom is x plus 10 minus 3 squared, so that's x plus 1. And then for x plus 4 and x plus 1, it cancels off. So this is the surds portion. Obviously, this cannot be the whole question because now is that I still need to minimize this. So part 2 is going to be that view this as a quadratic. This has been an OSMO senior question with different numbers. The way that we make it into a quadratic is to do a substitution. Okay, and then we will complete the square, although you can kind of tell that with completing the square, you expect that the over 3 is going to show up. So y can certainly be 2/3, no problem there. So therefore the minimum value is option B. Do not assume that x is going to be an integer, okay? For the SMO's final answers, even though it's multiple choice here, but for let's say the rest of the problems, integer final answer does not imply integer values of x, y, z, or whatever it may be. Question 3. Polynomial interpolation. Also typical SMO idea. And in my algebra video, this was one of the things that I mentioned about if a polynomial seems to follow a pattern but not perfectly, then you would go and do it in 2 steps. One is you will describe the pattern and write those things as roots, and then 2 is you will use the remaining other stuff to get the last undetermined coefficient. So here you have got P0 equals to P1 equals to P2 equals to 1 and P3 equals to 4, P4 equals to 9, and it is degree 4. Again, I will say that the pattern is sort of around there. It's like, wait, 11149. It's like half square number, half constant. So actually either way of doing it is going to work. So you can use the first three values and say that this has roots x equals to 0, 1, and 2. Therefore, by the factor theorem, there is x, x minus 1, x minus 2. Sorry, bracket is in the wrong place. The bracket is supposed to be here. X, x minus 1, x minus 2. But it's degree 4, so it's not times a constant. This is, there is still space for one more degree. So times ax plus b. And then now you can sub in x equals to 3 and 4 to find a and b. So this gives you 3a plus b is 1/2. This gives you 4a plus b equals to 1/3. Subtract them, you get a is negative 1/6. Put it back, and you get b equals to 1. So p of 5. Sub in 5. And p of 5 equals to 11. Now, you could have shortened this a little bit, however, if you actually realize that the square pattern fits even better. So this is the more obvious thing that you can do, but you could also have fit it against the square pattern by saying that, look, the three things after that are basically px equals to x minus 1 squared. But the x minus 1 squared actually will fit 0, 2, 3, and 4. So that would be even faster, because you can then say that, oh, so therefore px minus x minus 1 squared is some constant times x, x minus 2, x minus 3, x minus 4, and then just sub in x equals to 1. So this would have shortened your working a little bit. And that was actually sort of the slight optimization you can make for question 3. Okay, question 4 and question 5 is when you know that you are doing a hard SMO paper, i.e. My kind of paper, because it is like, wait, what? Why do I have 2024 to the 2024 in my tangents? But also, for anyone who has solved it, you realize that I've chosen basically it works really well. These are very considerate numbers. The SMO numbers, let's say when you see 2026 being spammed everywhere, right? Sometimes they're just there because it could just be n, but once in a while I am using it and they are using it because it makes things nice. Okay, so the question here is compare these tangents. To compare these tangents, first of all, it's like I want to reduce them down. How to reduce them down? I know that the period of tangent is 180 degrees. Not 360 degrees. 360 degrees is for sine and cosine. Tangent's period is 180 degrees. Therefore, you can just find what are these things mod 180. also because you know that comparing tangents is simple. Your graph of tangent for the 0 to 180 is going to be like this. Your asymptote at 90 degrees, and first quadrant positive, second quadrant negative. Right? So that will be enough as long as I find this mod 180. Now, to find this mod 180, you can use the Chinese remainder theorem, which we are going to hear more about from probably an hour and a half from now. Your Chinese remainder theorem allows you to split open 180. It doesn't need to be split all the way down to 2 squared times 3 squared times 5. Because 2025 is 45 squared, I can just split it into 4 and 45. And that is going to be more than enough. With 4 and 45, the nice thing is that these are both 0, mod 4, and this is 0, mod 45. This is 1. This is 1. And this is 1. So literally all of these are nice. Now we're just left to use the Chinese remainder theorem's permission slip to say that, okay, I can find this thing mod 180. I can find this thing mod 180. So I will combine the first two, just list out the things that are 1 mod 45, and you get 136. That will be the same for here because it's also 0 and 1. And then for this one, 0 mod 45 and 1 mod 4 is just 45. Okay. So one last trap that unfortunately some of you fell into is that then you just like your brain blanked because you thought that tangent is just increasing, but increasing is from 0 to 90, right? These two are in the second quadrant, so they are both negative, and this is positive for your tangents. Of course, tangent 45 degrees is 1, and tangent 136 degrees is quite close to -1. Okay, so the answer is that A and C are equal and less than B. Okay. Remember I said look at the timer. Now it's 1:30, so it's been 17 minutes. I think with a lot of me talking and all. Not easy, but still survivable. Okay, question 5 is where you definitely know that you're doing a paper by that is not like a normal SMO because the SMO definitely has the right to do something like this. They can assume that none of you know Swahili, but I wanted to set a logic question, and this felt like a funny way to do it. A logic come algebra question. So basically, the problem statement is just like so XYZ something 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 something, and you know that there are these two equations about XYZ. One is that they sum to 6, and the other is that their sum of squares is 21, and that they do exist. Right? The fact that they exist is guaranteed. So which of the following could be the first half of the sentence in English? So under what conditions would XYZ exist? Now, the first two basically already say integers, so you have got just a little bit of just checking how can x squared plus y squared plus z squared be 21 for integers. The only way it can be is you can check the small numbers, 16, 4, and 1. That would be plus minus 4, plus minus 2, plus minus 1. That is certainly not going to give you x plus y plus z is equal to 6. So these two are wrong. Now, x, y, z are in an arithmetic progression. That one, well, we can check. Arithmetic progression means a common difference. And so for option C, what I would do is to just use x, y, z to be y minus d, y, and y plus d for symmetry. You add them. Of course, it tells you that 3y equals to 6, so y equals to 2. And then you check whether the second equation has roots, which if you solve, you are going to end up with this is 12 plus 2d squared equals to 21. There's no more integer constraint in part C, right? So this is perfectly fine. So that means that already you know that option C works. So great. Now I chose to put it at option C. Even the order of the options here is meant to help you a little bit, right? Because D and E would be mildly annoying to do. D and E would be mildly annoying because if you wanted to check those, the logic is using some smoothing argument that will confirm that in both cases, x squared plus y squared plus z squared will be not big enough to reach 21. Right? Because if let's say that x, y, z are greater than 1, it means that the maximum you can get to is 1 squared plus 1 squared plus 4 squared, which is too small. And if they're sides of a triangle, the maximum you could get is if you head towards 3, 3, and 0, which would sum to 18 as well. Right? So I would say that that would be kind of annoying to have to do in a round 1, but this is question 5, and plus I put the option that works ahead of it, so at least to mitigate that a tiny little bit. Okay, so that's the multiple choice. Despite the slightly weird multiple choice section that I made, I realized that most of you did pretty well in the multiple choice section, so that is good. It is also a pretty funny thing if you consider that I'm telling you that 7 is probably enough for honorable mention on this paper, maybe even 6, which means that yeah, if you have a paper where 6 out of 25 is supposed to give you something, or 7 out of 25, you are going to naturally feel pretty hopeless. Like it's not going very well. So part of this paper is don't give up. The SMO paper will be potentially a bit easier, but even if it isn't, don't give up. Every one extra point you get can push you up one level. If the cutoff is low, bronze and silver or honorable mention and bronze can even be 1 point apart. Alright, so every single question you do does matter. Okay, so like I said, every 5 questions I will refresh Microsoft Word just so that it doesn't lag so much, and my voice to writing is more synchronized and my handwriting will not be so bad. Okay, so that's what's going to happen every 5 questions. Okay, I think the biggest culprit for why this feels very like infuriating is that questions 6 through 10 are not as easy as the usual question 6 through 10, and that is where a lot of the points do come from, right? So last few years, you will find that most people who qualified basically did 9 of the first 10 and a handful of other questions. Here, that may be a little bit more challenging. So that is probably where the biggest culprits are. But I will say that in such a situation, you would rather pour your time into making sure that you get the doable questions right. Because I see a lot of you where your answers are clearly a careless mistake away from being correct on the easy questions, and that is very, very painful. Yes, so for the question 5 just now, yeah, XYZ do not need to be unique. That's why I say part of a question, right? So it's just XYZ exists is what is given. So as long as XYZ exists, that is enough. Not necessarily that there is a unique XYZ. Otherwise, for arithmetic progression, the order could have been reversed. Okay, question 6. This was pretty well done still. Log questions are very hard to set to be interesting. Because compared to your list of trigo identities, the log identities are very short. So as a question setter, it is always that I'm going to try to do a fusion of log with something else. And log with algebraic identities is sort of one of the first things that we will try. You can see that there is ln 2, there is ln 3. These are not going to simplify. There is ln 72, and 72 is 2 cubed times 3 squared, which is 3 ln 2 plus 2 ln 3. And so therefore, what I'm going to do is just that I will let these be x and y. And put these things in. Yes, sorry, I'm just looking at the chat from time to time because too many windows on my laptop. Yes, inequalities like AMGM, Cauchy-Schwarz are in SMO Senior. You don't expect to see any of those inequalities used more than once in a paper, but it's possible to, let's say, have one question use AMGM and one question use Cauchy-Schwarz. Possible. Okay, so x equals to ln 2, y equals to ln 3. I will just substitute it in. Although you could use your a cubed plus b cubed plus c cubed minus 3abc identity, that also can work, but you don't really need that because you can just directly expand and cancel. Okay, so this will make the middle terms the survivors on top. Right, so this is the two middle terms. And then when you cancel, 3, 3, and 2. Now, a theme of these few questions that we have here actually is I'm going to recommend that we do these substitutions. They are not completely necessary every time. But when you do substitutions, what you are doing is essentially black boxing some part of the expression for a while. Right? This is also how, if you do coding, you know that, let's say you define a function, right? You don't just write your code as like 200 lines of procedural code. You will sort of define several functions. And it's like, okay, so now this function, I call it when I need it. Otherwise, I don't need to worry about it. So you want to be able to separate out things. And that's also what you will do in question number 7. When this is expanded in full, how many terms are there? The answer is 60. I'll just mention first because a lot of the answers I see are quite close, and I suspect it's just computation or you wrongly forgot to plus 1 in some places. Because when you take something to the power of n, you have n plus 1 terms for a binomial. Now, you will see that in these two, the A and B are in the same direction, but the C and D are not in the same direction of the sign. Right? They are flipped. Therefore, I know that these are so-called like conjugates in a way, where when you expand, things are going to cancel. I will do this first, just noting that x and y are actually not just a single term, right? It will be substituted back later. And so you've got these sums of powers. The expansion, you know that from your binomial theorem, it will, well, I don't even need to actually get the coefficients, right? There will be x to the, I mean, there's 2x to the 7, but otherwise there will be something here, something here, something here. And then that is already enough for me to know that the four of these types of things, when I substitute back, they are not going to blend, right? Because x to the 7 means all A or B's. Then x to the 5y squared means 5 of A and B and 2 of C and D. So each of them is going to do their own thing. So all I can now have to do is to just handle them separately. Remember that power n has n plus 1 terms, right? So the number of terms, power 7 has 8, power 5 has 6, power 2 has 3, and so on. So 60 terms. In the comments, there were a couple of you who were like, how do I, do the calculations faster? Between now and SMO, you can't improve your calculation speed, right? Let's say that you can't multiply two-digit numbers faster, neither can you estimate square roots faster, neither will you be able to expand things faster in the next 4 days. You can only try to reduce the number of steps needed, as well as to kind of take away unnecessary computations. So that is the sort of thing I'm trying to do in a lot of these questions. I don't like to make you do pointless computations, but I do like to make you think that I am making you do pointless computations, because that's also what the SMO does. So it looks like as if I'm going to make you just like drain a lot of time. But we have talked through 7 questions and it's only just about 30 minutes since we started going through, right? It is actually supposed to be, there are efficient methods for almost everything. Now, same for question 8. You have a sequence. You have a sequence starting at 1. Now, I have a sequence, I'm supposed to get floor of A 2026. This means that probably the answer is 2026. No, it doesn't mean that the answer is not 2026. It means that the sequence must be possible to understand, because otherwise I can't jump all the way to there. But normally when we calculate terms, I will say that the strategy is to try to calculate the first few terms, and yet if you calculate the second term already, you're like, no, this is bad. A2 cubed times 2025 equals to 2026 squared means what? A2 cubed equals to 2026 squared over 2020. I'm not going to calculate A3 after this. Actually, wait. What's so bad about calculating A3? Because I have cube roots, but you're cubing it again. All of these are cubes. So what's so bad about the cube root? In fact, you don't need to even worry about that if you once again do a substitution and just swallow that up so that this is a lot less ugly. And in general, that means that your recurrence is this. But wait, if let's say you're like, it's still very ugly, you can do another substitution. At this point, you can do substitutions as in like, I can calculate V3, V4, but if like this is too ugly, well, I can also try to cancel off a 2026. How? Let Bn equal to 2026 Cn. So you cancel off 2026 here, and you also will cancel it off here, and you end up with this. So I think I'm happy with that. I'm going to just find the sequence of C's instead. Right? So this is going to be the easiest thing to compute ever. If it's 1 over 1 minus Cn, I know that the fractions are not going to be too hard to work with. Okay, so B1 is 1, C1 is B1 over 2026. So I just compute that. And then you realize that, oh, we are back. Yay, we are back after 3 steps. It's just that because of how ugly looking it originally was, some of you literally just stopped at like at A2 or A3. You're one step away from the thing repeating. This 1 over 1 minus x is a very common functional equation filler, right? You know, the kind of functional equations where they just loop around. 1 over 1 minus x is a common filler. So it is something where if you do this 3 times, you will get back to itself. That's what I make use of, but I just kind of put the 2026 there to block you for a while from realizing this. Yeah, so of course this would imply that the period is 3 of A, B, and C, all the sequences, and that means that A2026 is actually the same as A1 because of 2026 is 1 mod 3. So for sequence questions in round 1, it often turns out that either the sequence is just going to be periodic like this, or it's just like an AP or a GP in disguise, or maybe it's just like some square numbers or some polynomial. Like the sequence is often not going to be very complicated, so you want to test it. The problem here is that the numbers make it hard for you to test. So you can always try to do some things to make your experimentation a little bit easier, right? Even though the correct approach is still to try to list a few terms. Okay, question 9. Stack of absolute values. Also meant to look very infuriating, but not so bad. What you can do is just to realize that you can factor x out of everything so-called. I'm not going to actually do that, but the point is that it is more like the only 2 cases are x are positive or negative. Everything is going to be taken care of the same way in terms of the adding and subtraction for each separate case. So therefore, I'm just going to be very carefully checking both cases. When x is greater than or equals to 0, I am going to go from inside to out. So this is x, 2x minus this is x, 3x minus this is 2x, 4x plus this is 6x, 5x minus 6x is absolute value of negative x, which is still x. Okay, so therefore this tells me that, oh, x equals to 630 just works. Then you go to the other side, which is if your x is less than 0. This one you need to be a bit more careful. The absolute value of x is negative x. Then this next layer will be negative 3x. Absolute value of 6x is negative 6x. Absolute value of negative 2x is negative 2x. Absolute value of 7x is negative 7x. So this would give you x equals to negative 90 as the other solution. And then of course you sum them up. No, right? I've actually got people who wrote 720. I also have people who wrote 2. Obviously, I know that by the time you finish, you're like, oh, there are 2 solutions, you wrote 2. The kind of careless mistakes that you see when you actually have just a Google form that summarizes all the different answers you get is like pretty sad. Right? Some people fill into the wrong question, some people add wrongly, subtract wrongly. Yeah. If it happened to you now, better than the actual SMO, is all that I can say. Okay, we'll do question 10 and then we'll take our first break. Two circles centered at O1, O2 respectively at equations, well, these are normal equations of circles. A common tangent L is drawn to the two circles and it meets line O1, O2 at P such that P, O1, O2 are collinear in that order. Okay, so find absolute value of A plus absolute value of B. I will start by just finding out the equations of the circles in the usual form, what is going on there. I'll line break it so it's easier to see. Okay, so I'll just 6 squared. And this one is 7 squared. You make your own jokes. The x minus 4 squared plus y plus 1 squared, x minus 9 squared plus y minus 11 squared. Of course, these are equations of circles as per normal, so I can draw the equations of the two circles into graphs. O1 has center 4, negative 1 and radius 6. I think I should move my y-axis a bit more towards here. And my, because most of the action happens high up, so maybe I'll do it that way. So 4 minus 1 with radius 6. And then the other one is 9, 11 with radius 7. Slightly bigger. Now, I'm not even drawing it too accurately because I want to just stop and think. What am I actually doing? I'm finding a common tangent. It meets line O1, O2, so this thing here, at P such that P, O1, O2 are collinear in that order. So, wait, where's the common tangent? Well, it's line O1, O2, right? So it means that the point that it goes through is somewhere here, which means that I need my common tangent, and you see I'm zooming out because it's like, wait, how far is my common tangent supposed to have to go before it can touch both of those? And then you end up with a pretty bad looking diagram. It's okay to have an ugly diagram as long as you realize that it is geometrically significant. In fact, it turns out that if you check the distance between the two circles, the two circles are actually tangent to each other. The circles touch. But that doesn't actually matter to this question. You do not need to know that the circles are touching for that to work. I guess more importantly is that when you see a coordinate geometry question, you don't assume that you're just working with coordinates the whole time, right? You are working with actual geometric objects, so you can use some geometry. And what I'm going to do is that I do not want to work with this very ghastly diagram, although it is not worth to try to draw this better. I'm just going to pluck it out and say that it's just similar triangles that will do the job for me. I know that the radii of these are 6 and 7, and O1, O2, the distance between them I can find. And as I said, you will realize they're actually tangent to each other. Right, because this is 4 minus 1, this is 9 and 11. And so therefore, why you will never really be able to draw a reasonable version of this diagram is that by similar triangles, you can just say that by right, this should be 6 and 1, and this therefore should be 6 times of that. Or equivalently, it means that you can use just vectors if you prefer. If you don't prefer vectors, you can just say that that means the change in the x coordinate and change in y coordinate will be 6 times of those two things as well. This gives you x equals to negative 26 and y equals to negative 73, and therefore, that's supposed to be AB, right? Yeah, fine. It's called AB, then never mind. The xy equals to AB. So your answer is just 26 plus 73 equals to 99. This point P is known as the x-simile center. That means the external center of the homothety between the two circles. There is an x-simile center and there's an in-simile center. You do not need to know any of those properties, but basically it technically can also be motivated from that way if you happen to have heard it before. Okay, so this is a good time for our first intermission. We have gone through 10 questions, which I think is at a decent pace. We will take our break. We come back, we'll probably look at something around like the next 7 or 8 questions. Okay, so for those of you who join in a bit later, before we resume, remember that I said these are the estimated cutoffs based on what I have gotten in terms of responses. It is not a fixed percentage or fixed score for round two. Genuinely, it means that there is we are only just sort of feeling that, oh, if it's a bit harder, then the score goes down a bit. If it's a bit easier, the score goes up a bit. But there isn't really a fixed guideline. It's not in the official rules. It's also uh, not very consistent sounding, to be honest, because even the number of people who get into round two is not like, it's not obvious what the pattern is. So there is only just a rough gauge. But once again, this is as for senior. Senior cutoff has been pretty low overall in the last few years compared to both junior and open. So don't try to overreach, meaning that it is okay to aim for something a bit lower, let's say, as your initial plan going into the SMO. When you go in and you actually see the paper, hopefully you will know whether it's like a fair difficulty compared to what we have, or has it gotten even harder, or has it gotten a bit easier, and then you can adjust your expectations accordingly. Just flip through the paper at the start and see what it looks like. Okay, otherwise we are going to look at questions 11 onwards now. Beginning with this one here, which is very much a question that I think frightened everyone off. It only really uses two simple separate things, but that alone can make things a bit scary. Now, the first thing to note is that your task is, it has real solutions X for Y is in this range, just basically means find the range of this. That is the question, right? Has real solutions. Now, when I say that this has real solutions, the default understanding is at least one real solution, right? It doesn't need to be two, but if you thought that it meant two, then it would not even be a close bracket inclusive of boundary, so you would then infer that I meant solutions as in at least one. The next thing is that once you want the range of this, the question is, how are cosine inverse and sine inverse related? And the answer is that they just add up to pi over 2. This is a pretty well-known statement because sine and cosine is sine of the complementary angle, right? So how did my cosine inverse and sine inverse end up adding to pi over 2? It just means that these are complementary angles, right? They are complementary angles because the x came from complementary angles. One you took sine, one you took cosine, you end up with the same thing. Therefore, this is going to be true. And therefore, all that this thing is just a quadratic. One more thing that we need to know is that sine inverse has a range from minus pi over 2 to pi over 2. And so with that, you can just substitute in just y equals to sine inverse x. Not y, let's not use y. Z equals to sine inverse x, y is in the question. And then we just complete the square. So within this range, it is entirely possible to hit it. So you can get z equals to pi over 4, giving you pi squared over 8, which means that y is 1 over 8. And the maximum would be when z is as far away as possible from pi over 4, which is when z is negative pi over 2. Not when z equals to 0 or pi over 2, it's when z is negative pi over 2. If you have this negative pi over 2 here, you can choose to sub it into here, you can choose to sub it back into there, wherever you want. And ignore all the pi squares if that is confusing you. It is going to give you 5 pi squared over 4. So 1/8 to 5 over 4 is your interval of stuff that are attainable. Obviously, everything in between is attainable. So that means that your answer extraction here is just write 1854 down. There are some of these like senior questions that are like 考知识 lah, it's just, do you know this particular fact? I mean, if you're doing all your other science Olympiads, the entire thing is do you know facts. For math, not entirely, but once in a while you just have to encounter a question where it's like, oh, this is the first time I realized this. Now I know. Good. One less thing that I can be tricked by the question setters because I was not aware of it. And that's all you can say. Because given this information, the question is not very hard. Okay, question 12. So this was sort of one time when I was in secondary school. There was this I don't know what it's called, right? There's some things or some math activity organized by MOE that you go to some school. There are some like workshops and all, and then there's like some amazing race. And then I remembered that there was some clue for the amazing race that time, which was double parabola. Which is McDonald's lah, right? So then I realized that, hey, actually that's a good idea to go and make a question using this logo. Anytime whenever you are setting questions, you start to look at everything as a way of setting a question, including McDonald's. So the two copies of a quadratic graph are separated horizontally by d units. Now, that means that this and this are both referring to d units. This is also the x-axis. So I don't know where the y-axis is yet. The logo passes through the points 5, 15, 9, 15, and 15, 15, two of which are marked with crosses in the diagram below. So I didn't mark all three, I marked two of them just to give you one small bit of thinking. But basically it means that this line is y equals to 15. Now, obviously, if two of them are marked with crosses in this diagram, it means that this one must be the 5, 15. That's the leftmost one. Right? There's nothing to its left. And then the question is this one 9 and 15? Or is this one 9 and this one 15? Well, we can rule out the 9 and 15 here because it would make it such that this distance, which is d, has to be bigger than this distance, which is smaller than d, right? So if you put the 9 and 15 here, that is not going to work. So it implies that, okay, actually the 9, 15 is there and the 15, 15 is there. Just a tiny bit of like a logic kind of puzzle within the quadratic. And once you have that, you are almost done. You just need to extract out the, first of all, because I want area, the base, I need d. With these 2 points here, it just means D is 10. Right? This is the amount it's been shifted. Now, then I need the height. If D is 10, it means that I can just focus on one of the quadratics, let's say the one on the left. I can draw its axis of symmetry. This is 5 and 9, so the axis of symmetry is 7. D is 10, means that here and here are both 5. So that means that these are 2 and 12 are the roots of the quadratic. Sorry, x minus 2, x minus 12 times some constant is the quadratic, and then you can use the 515 or 915 to confirm what is the value of C. You could also have done this with 515 and 915. You could also have done this with like the completed square form. Anyway, I'll just sub in. So C is negative 5/7. And then I can plug in the x equals to 7 to get the height. This is the height of the rectangle. Therefore, A equals to 500/7 and floor in order to get the answer extraction. I get the feeling that for some of the questions like this, if I just told you, please just take 15 minutes to try to solve this one question, you could. A good sort of mindset to take is that after the first half of the contest, generally speaking, you're just left with hard questions for you. Right? When I say this, meaning that if let's say that you find that after doing 5 questions, you find the rest hard, fine. If you do 10 questions, then you find the rest hard, fine. Now, once you go past the point where everything looks hard, don't worry about like trying to do things quickly, and then you just sort of jump around and just are in a state of general panic and nothing happens. Right? Just focus on solving one question at a time. No matter what pace it is, of course, try to find shortcuts, but don't worry too much about like how much time I have left. Like solve the easy ones first, and by easy means look through all 25. Anything that you kind of immediately know what to do those first, and then when you're left with stuff, then you can kind of slow down. 13. 13 is a bit deceptive because it doesn't look that bad since you have got tangent 30 and tangent 60 degrees. Like, those are special angles. How hard is this going to be? But then you've got tangent 40 and tangent 50, and you have got cosine 20 degrees. What do I do with those? And then why is 12a squared supposed to be nice? Okay, so here's just a suggestion that you should, for some trigo questions, don't substitute in the special angles if they are in some kind of symmetric form. Maybe it is fine to not actually substitute it in. Okay, and instead ask yourself, is there something that I know about tangent x plus tangent 90 minus x? Do we know something about this? Well, 90 minus x is complementary. So it's cotangent of x. You can then convert it all to sines and cosines. the top is 1 and the bottom you can just simplify into this. Okay, so that is to say that I now have a way of getting rid of the tangents nicely and symmetrically. When you see any like repeated structural feature in an algebra question, ask yourself whether you can first generate your general identity rather than to just write them all down, let's say, because this is actually a good way to handle both of them, even though the 30 degrees and 60 degrees are special angles. Okay, so the first one is x is 30, so it's 2 over sine 60 plus 2 over sine 80. Yeah, of course. So when a question like this is set, of course, I am not going to have decided that cosine 20. It means that I'm trying to just, the real question is here. And then after that, I'm like, simplify this. And I'm like, oh, I can simplify it to something related to cosine 20 degrees. All right, then let me just ask the question with a cosine 20, right? It's like, that comes a bit later. So I will multiply the top and bottom by the sine 60, sine 80. And then now I will sum the product on the top. Right, sum the product on the top because this would be 70 minus 10, 70 plus 10. Be 2 sine 70 degrees cosine 10 degrees. And then you realize that sine 70 cosine 20 are the same, sine 80 cosine 10 are the same. So at the end, of course, you substitute in the sine 60 degrees is root 3 over 2 so that we can compute the final answer. Okay, question 14 is actually one of the most difficult questions, even though the solution is pretty short. It is one of the most difficult questions also just empirically because the number of different answers I got for this thing was almost more than any other question. And it is not meant to be an easy problem in the sense that I know that this kind of combi questions are not that easy because finding the right approach is one challenge. It's also very easy to come up with an approach that you thought is right but it's actually not correct. So here is how I will choose to do it, although it is not the only way. Firstly, because I'm trying to have at least one number not picked by anyone, I know that it is going to be that, let's say that if I say I don't pick this number, well, your unpicked numbers, because you are grabbing, let's say, arcs like this, your unpicked numbers will also form a block. So I kind of want to split by cases of like, what is the length of the unpicked block, right? Let's say that, oh, so if I didn't pick this number, let's say this one number, then it's like, okay, there are 11 numbers left in a line, and then I am just picking 6 of them in some way. Now, you could split into cases in this fashion, it will work. Meaning that, okay, so 11 numbers, in order that this 1 is the leftover, you must pick this 6 at some point, pick this 6 at some point, and then all the remaining ones, you have a certain number of choices. Which is that in, let's say, for 11, you have got a total of 6 different choices, and after you have 2 of them do this, but then you're like, but the people are different, and what if more than one of them picks this thing? And then you get confused again, right? So whenever you're like, oh no, that's getting bad, then we probably want to just pause a while and see whether we can untangle it, because what I just said is getting more and more confusing already. Now, the unpicked numbers form a block. Let's say that instead of deciding on the entire block that's unpicked by rotation, let's just pick one direction of it. Right? So suppose it starts from 1 clockwise. Right? So the unpicked block starts from 1 clockwise. Now, if the unpicked block starts from 1 clockwise, it means that 12 is not picked. Sorry, 12 is picked, not unpicked. So 12 is picked. Now, if 12 is picked, then someone picked 7 to 12. And if someone picked 7 to 12, that already is enough to ensure that it starts on 1 clockwise. The rest can do whatever they want, unless, of course, they go and pick 1, which you don't want it to overlap. So this is a better formulation, because it just means that there are a total of 6 choices for each person, of which ones to pick if they exclude one number. So if there are 6 choices, you just have 6 to the 5 minus of the case where none of them pick 7 to 12, which is 5 to the 5. And then don't forget to multiply by 12, because I suppose that it started from 1 clockwise. So it can also start from any other number. The unpicked ones by symmetry, it will all be the same. Okay, this is hard. So the thing about reading solutions from the book last time, right, before I did my YouTube, is that everyone tends to think that, oh, this question is quite easy. The solution is just 3 lines long. And I say, no, it's not easy, but the solution is just 12 times 6 to the 5 minus 5 to the 5. I say, yeah, but then if let's say that you haven't seen the solution, it is not obvious. Now, here I'm explaining it, that it is not obvious, but I'm also saying that, look, a lot of these questions are like that, where your willingness to bash must also be tempered with some reluctance. Do not straight away say that, all right, I'm going to split into a whole lot of cases. Only if you cannot do anything better. Okay, question 15. Almost everybody guessed 2001 just from x equals to y equals to z. If this were the SMO, that's probably a good idea, because the SMO often will be like, blah, 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 oh, it's just they're all the same. Blah, blah, oh, they're all 0. Blah, 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 no solution. Then you just like, 很苦. When you have this kind of system of equations, that makes sense, right? It's just that I am telling you that it does not turn out to be the only solution here. But we can find that usually they will be the same. And the way that I will do that is because these are equations that are symmetrically defined. When you have got symmetric equations, you like to do symmetric operations. What I will do is just sum everything. If I sum all of them, the x's, y's, and z's will get cancelled off. And you will be left with x cubed plus y cubed plus z cubed equals to 3xyz. Now, some of you here will be like, AMGM. Too loud, right? But that's probably how excited you are. And that is minor flaw because negative. AMGM doesn't apply to negatives. AMGM only applies to non-negative. So yes, if they're all positive, then they must all be equal. But the more correct way to do this is to factorize our classic identity with x cubed plus y cubed plus z cubed minus 3xyz. This is the typical factorization that you will probably encounter also in many of the past junior, senior, and open papers. And this second term has its further simplification that you probably also have encountered many times, which tells you that, okay, for that one to be 0, it's x equals to y equals to z. Right? So that is the thing that you all found. Well, I mean, if you tried this question, most of you just arrived at that conclusion or guessed it. And you can see that it does work. So at least that tells you that x equals to y equals to z equals to anything. That's the first 2001 solutions. The other case, however, is x plus y plus z equals to 0. And let's just see what that does. Right? It's in the SMO, if you have no time, honestly guessing 2001 is the best expected value decision. But if let's say that you have run out of questions to do, just take note of which questions you made an assumption to just semi-guess so that you can come back and check it again. Now, if x plus y plus z equals to 0, each of these ones you can replace. Let's say the first one, 3y plus 3z is equals to negative 3x. So I'll just do the first equation because they are all symmetric. I can move them over and I can factor out x from everything. So you realize that, okay, maybe x equals to 0, like one of them is 0, will do something interesting. So let's check. If x equals to 0, the first equation here is already fine, since I know x plus y plus z is 0. The other equations, let's just check what the second equation, well, if x equals to 0, then y and z are negatives of each other. So z would be negative y, y would be negative z. Let's say the equation there with x being gone. You get y cubed minus 9y equals to 0. And you would get, oh, okay, y equals to 0 or plus minus 3. Of course, 0, 0, 0 we've already counted, don't count that again. But 3 and minus 3, nothing wrong, right? If y is 3, z is minus 3, then of course the other equation is just swapping around, it will still work. So therefore, you realize that, oh, the 0, 3, minus 3 and permutations will work. So that is going to give you another 6 solutions, 3 factorial. It turns out that is now all, and I will just very quickly with maybe 2 or 3 more lines just confirm that that is all, because if none of them are 0, because once x is 0, then we know this is what you get. If any of them are 0, then that is also going to happen. If none are 0, then this equation will give you x squared equals to yz plus 9, y squared equals to xz plus 9. All of these will be true. And there are 100 different ways in which you can ascertain that this is not going to work. You could just add all of them, get the identity, and just check whether now is it possible for this thing to be equal to 27, for instance. You could do that, but an easier way would just be to subtract them. Which factorizes. And x plus y plus z is 0, which means that this is here, which means that since z is not 0, x equals to 1. And then likewise, all the rest are equal again. So that's no more solutions because that's what we had in the first place. Okay, so this is one of the legit tedious ones, in the sense that you can't avoid having to actually check the cases because there is a solution that is in that case. All right, so time for intermission for a second while I switch over to the next 5 questions. We will do a couple more before we take our second actual break. Okay, so question 16. The trick for question 16 is that Fm over Gm is just equal to M. And this is the point where in the paper, your brain is too short to realize that. And then after that, when you sort of, after the paper, you slow down and try the questions, then you get very angry that you skip this question. The thing can be just discovered because if your devices of n are d1 to dk, then Fn will just be, of course, the sum. And Gn is supposed to be 1 over the sum. It's like the sum of their reciprocals, 1 over them summed up. But you know that they do pair up to multiply to n. That's how devices work. Which means that I can also write this as n over dk plus n over dk minus 1 until n over dy. Right? Devices pair up to multiply to n. And so Fn over Gn is just equal to n for n. Now, I stashed some of these here that are actually meant to be like time savers and easier questions, but with the acknowledgement that it's not easy to tell that this is the one that is supposed to be easy. So if let's say that you again are running short of questions to do problems like this, is like there is nothing wrong with just trying out like the first few values of n just to see what they look like, or like try n equals to like a prime number and see what happens just to see, and then when you realize, hey wait, when n is a prime, it's just P plus 1 over 1 plus 1 over P is P, then after you start to get suspicious and realize this, then good for you. Okay, so the answer would just be sum up from 20 to 26. Now we enter the geom section, which I have so-called mostly quarantined the geometry section from everything else, apart from the quad geom one earlier. This is made up of 3 geometry questions that are perhaps not your usual profile, because I didn't give any like just pure angle chasing ones, right? All of these are something to do with lengths. I would say that round 1 is much more length heavy than round 2, because for round 2 a lot of those abstract angle conditions are quite difficult to translate into a round 1 question. So question 17, you have as shown in the diagram below, this is a triangle, D is a midpoint, AE, ED, you have another midpoint. And then you extend out the midpoint here, EF, another midpoint. And then I extend out CG and ask you that if AH is equal to 3, then what is AB? Okay, question for you. Do my midpoints look like midpoints? Yes, they are midpoints. I constructed it with GeoGebra. So, must be to scale lah. You can just go and grab a ruler and go and measure the thing and of course, if you measure and you go off by 1, then sorry lah, but you can, it is to scale. SMO diagrams are like that, is that some of them are like just to scale and some of them are just completely not to scale. But it is pretty easy to tell that this is to scale, just as we'll see in a second, 18 is not to scale. So when it is to scale, there is nothing wrong with just measuring as some of you have done. It turns out that this is 17. Sometimes it is very, very irritating that it's like, I missed out on getting into round 2 because my friend did the exact same questions as me, except that he took a ruler and measured this kind of thing. Is that fair? Well, I would say that no choice lah. This is just the format of the SMO. So whatever exploits you can make, just feel free to exploit. Anyway, the intended solution is just manner loss, manner loss, manner loss. You have got all of these ratios everywhere. And so the idea is that I will look at the order of the construction. So the constructions are of D, which is the midpoint of BC, so I already know the ratio is 1:1. Then there is of E, which is the midpoint of AD. So there's no ratio for me to deal with for E yet until I drew the extension from BE hits AC at F. So F should be at a fixed location. And so my first task is I will try to get the ratio that applies to F. The way that your manner loss works is that you use the ratios that you know as well as the ratios that you want and use that as your triangle. So here, I know this ratio, I know this ratio, I want this ratio, so I will manner loss on triangle ACD. Where BE and F, that is going to be your transversal. So we just go around in a loop, AF over FC, CB over BD, DE over EA. Remember that what you're doing is that you are just visiting the things that are on the straight line while touring around the triangle that you're actually working with. Okay, so this will give you ratio number one, AF over FC, CB over BD is 2, DE over EA is just 1. So AF to FC is half. Okay, so 1 is to 2. Okay, then I need to know where G is in terms of ratio. To know where G is in terms of ratio, it means that G is on this line. I just need to know where E is. Okay, so if I want to know where E is on this line, then my perspective changes. I say that, okay, to know where E is on this line, let's say that I know this ratio, I know this ratio. Let me also find out about this ratio, and then this will be the transversal line. Right, transversal because Menelaus works as one point on each line of the triangle. The three things are collinear. So therefore, I can go again. Menelaus on triangle BDE, BC over CD, DA over AE, EF over FB equals to 1. And again, you end up with BC over CD is 2, DA over AE is 2, so EF over FB is 1/4. So if that EF to FB is 1/4, that means that this would be 4 units, half a unit, half a unit. So it's like 1:1:6. And then finally, you are going to say that, okay, how did H come? H came from G. So I need to look for some triangle again where I arrive at H using all the ratios that I have. Similar to before, I am going to just, now I can pick almost any other line because I know all of the ratios except that HGC, I don't know the ratio and I don't care. So that would be my transversal. And I can pick this triangle. So there we go. You can substitute in and you will find that AH over HB is equal to 3 over 14, which means that HB is 14. Okay, and so therefore AB equals to 70. Okay, so maybe we will do 18 as well, then we can take our break. So for 18, you have a very disconnected looking diagram. You have got a few straight lines, you've got one random right angle, you have got a tangent line. I have told you the lengths here. AC is 18, so this is 3. And I've given you EF is 39. Now this one is definitely not to scale. 100% not to scale, did not make any attempt to make it look like it is to scale. Find BE. Intuitively speaking, I would say that not much seems to be happening in terms of like interactions are very little. I just gave you one tangent line, one right angle, and the rest of the stuff are just kind of connected to each other in weird ways where I've given you some lengths that are all over the place. When I give you some lengths that are all over the place, power of a point is most likely going to be how I will tackle it. For power of a point, it must be related to some points that are not on the circle, right? So D, E, and F are not going to be the thing. It also should be related to something that has at least a line that is going through the circle. So which means that I am probably interested in the powers of A and B. Now, from the geometry video, I think I mentioned this, that power of a point is used as a property of things are equal to each other, but power of a point also does have its so-called canonical representation, which is that if let's say I'm like, okay, what is the power of this point P with respect to this circle omega? It would be the same no matter how you draw the line, but the one that I prefer is going to be just draw the thing through the center. Right? So that the power of the point P is Px times Py is Po minus radius PO plus the radius is just equal to PO squared minus R squared. This is the canonical power of a point. Like if you were to say, okay, what is the formula for power of a point? Well, technically you can draw any line, but any line is like, I don't know the length of any line. So you can relate it to the distance per center and the radius. Now, the idea therefore is that I can see A's power of a point, sorry, the power of point A is 21 squared, which is OA squared minus radius squared. Now, again, you could technically just say it's Pythagoras because for the tangent line version, that's quite obvious. The power of the point B is BE times BF. Now, I don't know what this is. But I also know that just like the other one, it is equal to OB squared minus R squared. The thing is, I do actually know what this is based on that. Because OB squared and OA squared, the difference of squares, I can just use the Pythagoras to relate it to the 15 and the 3. I haven't used 15 and 3 yet, I only used the 21 and the 39. So how much smaller is it? Well, OA squared minus OB squared, if we use Pythagoras, OA squared and OB squared will both include OC squared, which cancels off. And then you can quite easily solve from here that BE equals to 3. Okay, so this is maybe a version of power of a point that you have not seen before as often, but it is useful in the sense that the difference of powers of a point is actually related in quite a nice way to the distance between the 2 points in a form like this. Okay, so we will now take the break until about 3 p.m. and then we'll come back and look at the rest of the questions. I suspect that for this, we'll probably end sometime around 3:45 estimated, in case you need to know a time. Okay, so welcome back to part 3. We will finish off the last 7 questions. Now, I'm going in order because this is a very obvious way that I would like to have a review video be. In case anyone comes in, or if you are watching this on a recording, I'm sure you would appreciate that I'm not just jumping around in order of difficulty, right? That doesn't make any sense. How are you supposed to find the answers to everything? But in reality, you would be jumping around. And so, among other things, it is going to be the case that uh, picking the right questions is rather critical for senior and also for open, which we'll do a bit later. Uh, Oftentimes, the problem is that the questions which actually have an obvious method take very long, and the questions which have a clever method don't take very long. So if you just try the questions that seem to have an obvious method that works, and your obvious method was not the fastest one, then you burn up a lot of time. That is okay if you're aiming for anything up to a silver. You can just pick the ones that you think you know how to do and take as much time as you need. But if you're aiming for, let's say, a reliable round 2 qualification, jumping around to whatever you have most comfort with, whether it be, you can't escape algebra, whether it be CG or N, feel free to jump to those questions wherever they may be. Someone asked me in the comments also for in the form that is like, how do you keep your brain functioning for 2.5 hours? The answer is that with practice, but it's still hard, right? So give yourself a break if you need to. But with practice, your brain will be better able to function for a long period of time. Just like if I am doing these streams back to back and I'm doing the open one later, you're definitely going to hear me during the open one say one or two obviously wrong things and someone will correct me, because doing a few of these in a row is tiring even when I'm the one that set the questions. Let alone if you are solving it when you have no idea what I am thinking when I set the problem. Right? So it's okay to sort of feel that, wow, this is very tiring. At the end of the SMO, you should feel tired. If at the end of the SMO you feel tired, then at least you know that you have given whatever you're able to, and then no regrets no matter what you ended up scoring. Okay, so pep talk number 2 is over. Let's look at the questions. In non-degenerate triangle ABC, the moment when you see non-degenerate, it's always a hint to make you think about the triangle inequality. It's not a very information-filled statement again. It's just, okay, D is the midpoint of BC. This is 9, this is 13, what is this? And then it's like, huh? That is enough? How can that possibly be enough? Okay, integer. And the numbers are small. So triangle inequality is probably going to combine with our whatever equations we have to limit it to just one value. Right? This is what we think. Now the question is, what equation? In this case here, the equation that I would like to use, I'll call these things x and y. I will use Apollonius theorem, because that's one equation that immediately will bind them together. Now, Apollonius theorem is for triangle and median. I think I mentioned it before in the one of the geometry videos, that you can also think of it as coming from parallelograms, that in a parallelogram, the sum of the squares of the sides is equal to the sum of the squares of the diagonals. That can be shown using the cosine rule. So this is technically just if you chop it in half, because if you then reflected it over, you get a parallelogram. Okay, so that is where Apollonius theorem can be more easily remembered. So 4x squared plus 4 times 9 squared, this would be the sums of the squares of the diagonals, equals to 2 times of y squared plus 13 squared. Of course, in this case here, because I can cancel off a 2, you end up with 2x squared minus y squared equals to 7. Now, the idea then is that you can simply start to do some listing with the help of the triangle inequality. You already have a starting thing, which is that by the triangle inequality, your bound for x is between 5 and 21. Now, I am not saying at this point that, so the correct way to do this is to check everything from 5 to 20. I think that sounds a little bit bad. You can, if you want to. What I will say is that this is where, again, optimizations come in. If you feel like doing a little bit of, let's say, number theory stuff, you can. Right? You can, for example, do mod 4 on this, which is to say that, so y is odd, means y squared is going to be 1 mod 4, which means that 2x squared is 0 mod 4, so x is also even. At some point, honestly, I would say that if you're talking about this range of values, you will just list lah. So I'm not going to go overboard in try to restrict further when I'm having a list of just even numbers from 6 to 20. We can, but I think you would rather I say list than say any other weird thing, so we'll just stick to that. Because anyway, it will just be the second thing, x equals to 8 and y equals to 11 will already work, and that is the only solution. So whenever there's an integer thing that randomly floats into a geometry question, it means that probably just write it into a Diophantine equation, except that the geometric stuff will help you to limit the scope of your search. Okay. 20 is probably the other one that is meant to be computationally intensive, right? So one of them that is meant to be computationally intensive was 15, and then this is the other one that is meant to be quite a bit heavier on computation. Now, you will have to do it by some kind of grouping, because your ordered pairs, x and y are at most summing to 26, still gives you a lot of cases. And it's a non-negative integer technically, but it's up to you whether you want to include non-negative or just positive, since if it's 0, then this thing would be 0. So it would disappear anyway. Now, I think what I would do is to group by the value of x plus y. Meaning that because for each value of x plus y, there will be a fixed minus 1 to the power of it. That means it's either plus or minus. So x times y will then be either all added or all subtracted. So really what I have is that if I let Sn be equal to the, well, the sum of all the x, y's that sum to n would look like this. Then what I want to get would be, okay, when I have 0 minus S1 plus S2 minus S3 to S26. This would be the final expression. So Sn, the sum of these things here, we would be able to just use our summation formulas. There's also some combi interpretation of this, but don't really need to worry about that. So sum from 0 or sum from 1 is the same. So I think I can just change it to 1 for convenience. Use my sum formula and my sum of squares formula. I can factor out the n plus 1 over 2. And you will end up with this is actually n plus 1, n minus 1 over 6. Which, okay, that actually is good because it is n plus 1 choose 3. Now, that means that I can use all of these things nicely because the difference of these s's would be my combi identity. Remember that, of course, S0, S1 are technically going to be gone. So you can throw them out if you want to. But I think I am okay with just leaving one of them here so that I can pair it up like this. By definition, anytime when you have something smaller, that is technically 0. So I can throw that out, or I can leave it there, even though it looks a bit funny, just for symmetry. The point is that we know this minus this would be equal to this, and so on for all the rest. Okay, so at this point, do we know an identity for this? I don't think so. So we probably just push it back into the summation again. So 2n minus 1 over 2. And then sum of squares minus the sum. Okay, so this is the numerical answer. Like I said, this one is actually the other thing that I think is computationally pretty intensive. You remember the weird combi identity question from last year's senior, right? So at the very least, you cannot say that this is the first time you have seen something of that level of ugliness or complexity. Oh, right. Okay, time to change over to our final 5. Question 21, this is a very famous function, and I don't know if any of you have seen it before. This is known as the Cantor function. It's known as the Cantor function after Georg Cantor, who is responsible for all the Cantor's paradox, Cantor sets, and all the weird things that you have in math that tell you that math doesn't work the way you think it does. A big chunk of them are his fault. Not my fault, right? Mine is HARDSMO, he's just hard math. So Cantor basically came up with this function, which among other things is sort of continuous almost everywhere and yet jumping all over the place, which is one of the more infuriating properties of a function. But the hard part about the Cantor function is not to find values actually. It's because these are very restrictive conditions and we can just understand it as follows. The first is that f0 is 0. And it's defined from 0 to 1. f0 is 0, and from the second thing, of course, if you put in x equals to 0, you get f of 1 equals to 1. This is saying that it's a non-decreasing function. And this is telling you how to get some values. Meaning that from fx, you can get fx over 3. Okay, so that's the only values that I can get so far. Is 0 and 1. I would like to get something else. So f0 equals to 0, f1 equals to 1. Because it's increasing, I'm going to draw it like in a line. I'm not drawing a number line, but just, horizontally. Okay, so from this statement here, f of 1/3 is equal to f1 over 2. So f of 1/3 is half. I can't 1/3 my way all the way to 1 over 2026. So I need to think of what to do. But first, with 1/3, I can also get 2/3. Right? F of 1 minus x is 1 minus this. It will also give you f of 2/3 is half. Now, this is the crux of it. That means that it's actually constant in this range. Because it's non-decreasing. So if f of 1/3 is half and f of 2/3 is half, everything in between is also half. And so that means that if I take this whole interval, if 1/3 to 2/3 means fx is half, anything in this interval, if I sub it into here and divide it by 3, let's say 1 over 9 to 2 over 9, it will be 1/4. And so I just continue on until I go past 1 over 2026. So 27, 81, 243, 729, and then 2187. So this is going to be the half, 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 half. So that includes f of 1 over 2026. Everyone's too tired to type in the chat, right? This paper is too exhausting. I understand the feeling. But that's also how the senior has felt the last few years, if we're being honest. It's just maybe not to this extent, but not far away actually, in terms of how it will feel like. Just that the cutoffs, like I said, don't depend on the hardest few questions. So normally in SMO, you're not worried about the hardest few questions. If we are talking about the hardest few here, then of course your brain feels like it is under attack, which has no relevance except to maybe the top 5 people. If we're talking about a paper of this difficulty, the hardest questions don't matter hugely. Okay, question 22 is meant to make you laugh a little bit if you have already reached this point within 2.5 hours. It is, of course, literally, do you know how the Chinese remainder theorem works? Because some of you may think that Donald Trump is correct. sentence you didn't think you were here today. Some of you may think it is correct, but the statement is not correct. The statement is missing a very important condition, which is that it needs the things to be co-prime. Right, so the Chinese remainder theorem, which is the correct remainder theorem here, it needs them to be co-prime, and how many ways are there to get U, S, and A to be co-prime and multiply to this out of the total number of ways that they can multiply to this? That's the probability. So firstly, let's just count the number of ways they can be co-prime. That's pretty easy. Because each of these factors have three choices. The co-prime means that they must take the entire stack of each prime separately. So there's 3 cubed. What if they are not co-prime? Then you still can handle each prime separately, but it is our classic appropriately stars and bars. Stars and bars is actually supposed to be from the US flag. That is sort of a not very funny joke by this point, but that is the intention. Stars and bars is how you will partition this. Let's say if 3 to the 4, so 4 objects, 2 partitions, there will be 6 choose 2, and likewise for the other 2, you will get 8 choose 2 and 10 choose 2. Multiply them. And then your 1 over p means that just this times this times this over this. So 700. The probability questions in senior, we don't see much, right? I mean, last year there was one, occasionally there's one. Very often the probability though is just one step away from normal PNC. So it can kind of work either way. This is know how Chinese remainder theorem works, and then know how this stars and bars works. Just put two together and you are fine. So that's actually pretty short. And this 23 is also pretty short because when I ask this question here, for some positive integers and the simultaneous equations x plus y equals to 2026 and 1 over x plus 4 over y equals to 1 over n have at least one solution xy where xy are positive reals. You must understand that this is not a Diophantine equation. X and y are reals. But because it's positive integers n, it is essentially asking you for the range again, just like question 11 with the sine and cosine inverse just now. It basically means what is the range of this 1 over x plus 4 over y. I think just now I wrote minimum twice, right? Some of you told me. So now I shall remember to write minimum and maximum first. So the 1 over x plus 4 over y can go to infinity. Right? If x just goes to to 0 and y goes to 2026, basically it just means that the 1 over x already goes to infinity. So the maximum doesn't exist, it's unbounded. As for the minimum, this is where you use your T2's lemma, slash Cauchy-Schwarz. Right? 4 is 2 squared. And clearly, because your 1 over x plus 1 plus 4 over y is also a continuous function, that means that you will be able to move and get everything in between. So all you have is just that this is supposed to be less than or equal to 1 over n. Okay. And all the 1 to 2 to 5 all work. Yeah, so that's your Cauchy-Schwarz slash T2s for you. Now, 24 is conceptually probably the hardest question. Because what is this? Now, I don't know if this will make sense to anybody, right? But the inspiration for this question is actually from a concept in cricket, the sport of cricket. Right now, the Indian Premier League is on. So, sport of cricket has a notion of like required rate. If you know nothing about cricket, basically it means that you have a target and you have a certain amount of resources left. How much do you need with each to score for each ball? So this is kind of meant to be actually inspired by that, whether you're above or below the required rate. When you see a very weird equation in round 1, it probably is just a weird way of describing something not so bad, right? So think of it as you put the digits one at a time. So the intuition is you place digits from left to right. You place the digits from left to right with a total target is 26. And that means that your average required per digit is 2. With each of the subsequent digits, what I'm saying is that this is sort of like the leftover. This is an above average for odd k. Of the remaining digits, and for even it is below. Of course, above means greater than or equals to. And the average required per digit is 2. So that means that, let's say for your first D1, your D1 is going to be just above average. Above average means 2 or 3. Now, if D1 is 2, that means the remaining average will be 2. If you put D1 is 3, the remaining average is going to be less than 2. So what happens is that, so if let's say I put a 3 and the average is now 23 over 12, I can only put 1 after that. I'm forced to put a 1 in D2 because the even K is below average, and that will restore the average back to 2 again. So it means that if this is 3, this could be 1 only. If this is 2, then this could be 1 or 2. But then if this is 1, then the next one must be 3 again. And so therefore, this is actually kind of a Fibonacci recurrence in a pretty weird way. I can let an be the number of ways for n digits of 1, 2, and 3, the sum to be equal to 2n and alternating between above and below average. So it means that once you have put the first digit down, if you put the first digit as 2, you are left with 1 fewer digit. But after that, you're alternating still, and you still have the sum equals to 2 times n minus 1, and you still have the same supply of digits. If you put the above average one first, then the next one is forced to be below average, and then after that, so let's say your first digit is 3, and then the second one is forced to be 1. Then you're back to the original situation again. So this is just going to end up being your Fibonacci recurrence. I talked about this in my combi video, but probably this is a much less obvious way that a recurrence could have been generated. Okay, so A1 is 1 as usual. That's just the first. If it's a 1-digit number, it must be 2. If it's a 2-digit number, then it can be either 2, 2 or 3, 1. And then after that, you just add all your Fibonacci numbers. I'm seeing a lot of people have disappeared because their brain has died, right? So if you need to, for those of you who are here now and you've been here the whole time, feel free to just digest it later. Playback will be available. Okay, last one is 25. And this is a combi calculus question, but actually not a very difficult one either. So I will argue that in the last section, depending on what you are familiar with, only that question 24 is meant to be really hard. 21, 22, 23, and 25 in different ways are actually doable. But with the time constraint, maybe you didn't get to that. So question 25 is that you have these things here, and Bob has 26 turns of differentiating one of them at a time. And then he sums up the monomials, which basically means just add the coefficients. The final score is just the sum of coefficients. And you want the smallest possible final score. What you can do is clearly, if I keep on differentiating, the coefficients keep getting larger. We know how differentiation works. It is not going to be small until you manage to make it vaporize. So that's what I want to do, right? I would like to make it vaporize to 0. That's the first thing. The second thing is, would I like to differentiate to 0 just at random? Well, I think I want more zeros, right? Because of the fact that they're all 100 and something. So rather than to just do a few big ones, it would make sense to do as many of the small ones as possible. Now, all of this can be technically proven in rather mundane ways. I mean, is that, do I really need to explain why I wouldn't want to leave something in between as some ginormous number? I think it's quite obvious, but technically speaking, it can be proven. So you want to zero the smaller degree terms. Now, we know that the number of steps needed would be in that order. So it's just, how do I add up to 2026 starting from the front? Now, a random fact that I remember from my, well, from ages ago is that 2016 is a triangular number. So if I take 2 to 63, that would take 2015 turns. And therefore, quite a number of you gave the answer that is, oh, that means that this corresponds to the first 62 terms are gone. And then after that, you gave me the answer, which is 63, sorry, not 60, 163 to 200. Because it's like, oh, I have 2026, so I can only do this. And then the last 11 more, I just differentiate a 0 to kind of just waste the turn. Unfortunately, this is not correct because we can actually do something more productive with the extra turns, which is that you can go to 62, and then the last 11 extra turns, you just go up here by doing that. You have basically replaced the 173, or more simply, you have managed to do a minus 11 because you have managed to go to something that has a coefficient that is 11 larger. Okay, so just compute this. And you will end up with your answer, which is 6886. I'm quite happy with this question actually. Just that I know that it came at the end, and so not everyone had time to look at it. Okay, so that's quite a lot. Let's take a few minutes to just round up before we all take a break. I will take a break before the open stream, and if you are joining, you can take a break too, or you can join in a bit late. It is okay. The hard questions here are hard, meaning that it is difficult if you are someone who is aiming to do the hard questions. It's difficult also if you're someone that is aiming to do the easier questions. But that does not both apply to you. Meaning that if let's say that you are aiming for round 2 qualification, whatever I've said in the past 1 hour, probably only 3 of these questions matter to you very much. Remember that the cutoffs that I have projected are substantively lower than what we have down there. Right? So you do not need to worry about these hardest few questions. Honestly, I think they are just interesting. If someone is watching this back like 1 year later, maybe at least with less stress, you'll find the questions fun. At the same time, for those of you who are stronger, who are aiming for, let's say, goal, top 30, you have to adapt to the difficulty of the paper. I remember that when I was in Sec 1, year 1, that's when I took the 2009 junior paper, which is almost as bad as the 2011 one that I posted up. And I came out of the paper, I think, with 19 questions and crying. I guess I've irritated you enough with a difficult paper. I can afford to embarrass 13-year-old myself. I was crying because I was like, that was really bad. Now, this was at a time where in 2008, you kind of needed like 20 questions out of 35 to get into round 2, right? So it was like, okay, I thought that was really bad. And then no one wanted to talk because everyone was too sad, it was too hard. And then it turned out that the cutoff was that time I said, right, something like 7 or 8 for round 2. I did not know that, of course, until much later. So if a paper turns out to be really bad, just adjust to it, don't panic. If, in other words, if you look something like what I have given to you, don't panic because I'm putting the cutoff here as 12 since the last hardest 10 questions don't really affect the cutoff. But it is very well possible that if this were actually a paper, enough people will panic that the cutoff is more like 10. It could happen. I really don't know how many of your stats would be affected if this were an actual contest paper. Okay, so don't get too panicked from this. I would rather you panic now than during the SMO, but at the same time, don't take it too far. And also, the advice that I gave at the start still applies, which is questions are not in difficulty order. There will be easy questions at the back. My easy questions at the back are not that easy, but the SMO does have really easy questions at the back. Also, please do guess. My questions often seem to be penalizing guessing, except for 1 or 2, but you can guess, and your success rate at guessing on the actual SMO is often going to be higher than it is on my paper. Okay, now finally, of course, there's been a lot that we have said. If there's any kinds of things that are a formula, like let's say Apollonius theorem, probably learn it. A theorem that is just a statement of fact, an equation, is easy to learn. Learning how to be better at combi or learning how to be better at geometry as a whole, a bit too late for that, right? If you're not going to suddenly become like a geometry expert in 4 days. So don't worry too much about upping your level massively. You just want to make sure that, okay, if I don't solve the geometry question, it's because it's too tricky, not because I didn't know, let's say, a fixed theorem like Menelau's theorem, right? If you know the theorem and you can't solve it because it was too hard, then never mind. So that's what you should do, whether it be A, C, G, or N. That's why I recorded all the videos with all the formula stuff, right? You can just look through it. You can fast forward through it if you think you're familiar. Just so that if you fail to solve a question, let it be because there was too little time or it was too clever, not that I forgot to study this one particular formula or this one particular thing. Okay, so I think that we are too tired to talk, and that's why the chat has just completely gone silent. This happens every year, right? The junior chat is very bustling, and then like there are all kinds of memes and all kinds of things. And then the senior chat is like everyone is just, they just died. It happens every year. This will remain up for playback. If you have any retrospective questions that I've missed out, please do write it in the comments and I'll try to reply. If you need to kind of heal a little bit and you weren't at the junior one, you can go and look at the junior paper, right? Just to feel a bit better about yourself, I hope. And also the past year papers. The past year papers are definitely not as scary. Although, as I said, the past year papers is some years had a lot of geom, some years had a lot of NT. So depending on your preference, you will find different ones hard. But not all of them will be as hard as what we just had. Okay, so any final questions you can just type in the chat. Otherwise, I will go off camera and we will take a break before I see some of you back in about 45 minutes for the open review. Everyone is still too tired to ask questions. Okay, I think we'll end here. So all the best, and then yeah, uh, let's hope that the actual SMO senior is not so scary. But I hope you found the questions to be sort of fun, and you definitely learn a few new things along the way. So bye. See you in a little bit.